What up, freshmans and womans, coming back at you for a third time. This time, again, we're going to be talking about balancing chemical equations, but we're going to tweak it up into our third method. And this third method, I like to call the fraction method. Booyah. You guys all love fractions. Don't lie to me. You love them. All right. So fraction method. Now, again, this is just a method to make things easier. You don't have to use this method, but it does help with some tricks. All right. So let's get going. Here we go. Now, whenever you do this, you might not know the fraction method is needed until towards the end of the balancing, almost at the very last step, and I'll show you when it happens. So we just balance this as like a traditional method. All right. So let's give you here a chemical equation. Let's give you, let's zoom in a wee bit, make it nice and close. There we go. All right, let's give you C2H6. That's ethane gas. You don't need to know that, but it's just fun. O2 gas yields carbon dioxide. You should know that one. And dihydrogen monoxide, aka water. All right, there we go. So let's start our balancing. Now we have no polyatomic ions. We don't have any compound here that has two or more elements in it. So let's get numbering them. 2, 6, 2, 1, 2, 2, and 1. All right, so again, you don't have to do this, but I always leave the simpler ones by themselves till the end. In this case, it's the oxygen because it's a single element. All right, so in this case, let's start with the big ugly, all the way left. That's kind of ugly, so let's start counting. 2 carbon, 1 carbon. All right, both 2 and 1 can go into 2. So 2 times 1 is 2 times 1 is 2. 2 times 2 is 4. 2 carbon, 2 carbon, 6 hydrogen, 2 hydrogen. All right, no big deal. We just put they both 2 and 6 can go into 6, so we just put a 3 up here. 3 times 2 is 6. That matches the hydrogens. And 3 times 1 is 3. All right, nothing too fancy. 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens, 2 oxygens, 4 plus 3, you got to count them both on this side, is 7. All right, so now we kind of have a problem here. We have 2 on the left and we have 7 on the right. Whenever you have an element kind of by itself like so, a lot of times you can just simply use a fraction to get to the right answer. Well, we have 4 and 3 is 7. So what times 2 can you get 7? And that's 3.5. Because 3.5 times 2, or let's actually just put it at 3.5, because I also like decimals. 3.5 times 2 is 7. All right, well, let's add 2 carbon, 2 carbon, 6 hydrogen, 6 hydrogen, 7 oxygen, 4 plus 3 is 7. Yay, we are balanced. But if you turn that answer in, you would get it wrong. And the reason you get it wrong or would get it wrong is because you cannot have half of a molecule. That doesn't make any sense at all in chemistry. So what do? Well, if we look at our number here, what whole number could you multiply that by to make that fraction no longer a fraction, but a whole number? Well, an easy one in this case, and the lowest one you could do would be 2. If you multiply 3.5 by 2, it becomes 7, a whole number. Now, listen, you just can't multiply a coefficient by a number, and that just makes your answer right. Like math, what you do to one side of a problem, a mathematical equation, you got to do to the other. So if we're going to times this by 2, we got to times everything by 2. So let's do it. All right. Well, I always like to put a line here because technically there's a 1 there. We just don't write it. So I'll cross that off and put a 2 because 1 times 2 is 2. 2 times 3.5 is 7. 2 times 2 is 4. And 2 times 3 is 6. So again, we multiplied the whole thing by 2. Now, you don't need to add that little brackets there that I did, but I just wanted to show you that we're multiplying everything by 2. And again, if you're like, why? Because we can't have fractions, can't have decimal answers. And the easiest way to get rid of this decimal is to multiply it by a whole number. In this case, the whole number that you can multiply a half by in 3.5 is 2. All right. So we now go through and recount to make sure everything's right. Now, it should be right, but let's do it again. 2 times 2 is 4. 2 times 6 is 12. 7 times 2, not 7 times 7, common mistake. 7 times 2 is 14. 4 times 1 is, dagnabbit pencil. These pencils kind of stink. But that's why you can buy like 50 of them for 25 cents. 4 times 1 is 4. 4 times 2 is 8. Don't multiply this new, multiply the answer. 6 times 2 is 12. 6 times the original 1 is 6. Let's add them up. 4 carbon, 4 carbon, 12 hydrogen, 12 hydrogen. 14 oxygen, 8 plus 6 is 14 oxygen. This is a balanced chemical equation with coefficients of 2, 7, 4, and 6. All right. Now, let's give you a practice one. All right, fun little practice one. Let's do C4H10. A little bit of butane there, found in lighters. A little bit of O2 oxygen. We like our oxygen. And they are going to chemically react and create carbon dioxide and water. All right. So go ahead now, pause the video, and let's see how well you can do. All right, go ahead and pause it. All right, welcome back. If you paused it, that's awesome sauce. Good job at trying the problem. If you didn't pause it, then I probably sounded like an idiot. Just saying welcome back. But here we go. So let's do our numbering like we do always. We have 4, 10, 2, 1, 2, 2, 1. All right. Again, the big ugly, probably that sucker right there. You can start anywhere, but it's going to be more challenging if you start with this oxygen. Okay, much more challenging. So 4 carbon, 1 carbon. Both can go into 4, so coefficient of 4. 4 times 1 is 4. 4 times 2 is 8. 4 carbon, 4 carbon. 10 hydrogen, 2 hydrogen. No big deal. They both can go into 10. So we multiply that 2 by a 5. Remember, what you do to one, you got to do to the other. 5 times 2 is 10. 5 times 1 is 5. 4 carbon, 4 carbon. 10 hydrogen, 10 hydrogen. 2 oxygen. And on the right, 8 plus 5 is 13. So again, what number can you multiply by 2 to get to 13? And what you can multiply by is 6.5 or 6.5. So 6.5 times 2 is 13. Let's count. 4 carbon, 4 carbon. 10 hydrogen, 10 hydrogen, 13 oxygen, 8 plus 5 is 13. You are balanced, but you are not right. You cannot have a fraction or a decimal molecule. Okay, so we find what number is easiest to multiply 6.5 to get by a whole number or get to a whole number, and that would be, again, 2. So we multiply everything by 2. So that becomes 2. That becomes 13. It kind of is also tricky. If you multiply by 2, it should get to that. That becomes 8, and that becomes 10. All right. 2 times 4 is 8. 2 times 10 is 20. 13 times 2 is 26. 8 times 1 is 8. 8 times 2 is 16. 10 times 2 is 20. And 10 times 1 is 10. Let's see if it works. 8 carbon, 8 carbon, 20 hydrogen, 20 hydrogen, 26 oxygen, 16 plus 10, because they're both on the right, the reactant side, is 26. This is a balanced chemical equation. The answer is 2, 13, 8, and 10. Now, again, you don't need to write this little 2. I did that here just to show you that I multiplied the whole thing by 2. In fact, I'm just going to erase that because that might confuse some people just trying to look at it here at the end, okay? And again, right there, there's a 1 there. All right, let's zoom out just a wee bit to kind of get it all. All right. If you have any questions, go ahead and ask any of your teachers over these 3 methods. Again, if any of these 3 methods didn't help you, then you are more than welcome to go online, search for videos. There are many other methods that probably work just as well. I found that these methods tend to work great with freshmen for these simple chemical equations. Peace.